Hey, what's going on? It's me with another algo question from Leetcode for you today. I'm doing one of these every day, and if you like what you see, like, subscribe, and don't forget to follow me on all the channels that I have, including Twitter, this channel, and every other channel that you can think of. Um, so yeah, I'm gonna today try to tackle another pretty straightforward problem. I'm having a few days of just warming up until I get to the little more meatier problems. So this problem is 1704. Determine if string halves are alike. So it looks like people like this problem generally. It's got 159 likes versus 13 dislikes versus this time, March 18th, 2021. I should have mentioned the date in the beginning, but here we go anyway. So the problem asks, you're given this string s of even length, split the string into two halves of equal length and let A be the first half and B the second half. The two strings are alike if they have the same number of vowels, A, E, I, O, U, capital A, E, I, O, U. Notice that S contains upper and lowercase letters. Return true if A and B are alike. So otherwise return false. Now this is pretty straightforward, and I don't even think um, you know you really have to think in any super complex way to solve this problem, right? The only thing is from a very basic point of view, you want to be able to count whether the string has the same number of vowels on either side of it efficiently, and it's an even string, so it should be straightforward to to quickly count this, because remember, you're just doing a lookup here. Okay, let's start. So first thing I'm going to do is define my lookup. Now, your lookup can be, typically one of two things, either like some sort of hash collections hash object, or I'm going to use a map, a map array. Right, and I'm going to say this map array has 128 characters, very small array. So the reason I'm not using an object like a hash map or a hash set is that the hash sets, these collection objects take up more memory on average, and they have more overhead in terms of access. So if you're really trying to make the problem more efficient, or as efficient as possible, you want to ensure that access occurs as quickly as possible, so you're making optimizations wherever you can. So arrays are very basic data structures, low level in Java, so uh, they should have quick access. So what I'm doing here is I'm making this a character array, right? So we can access this by uh, the character code, the ASCII character code, which I forgot. I think it's 65 for lowercase a and 95 or 90 something for capital A. Either way, the whole point is we are able to access these as regular integers, right? So A, E, I, O, U. Okay, so now I'm going to just say is that this is equal to 1. Okay, blah, blah. All right, so everything else by default would be 0. And you can easily prove that by printing that out. So now, the trick here is we want to check both sides of the array, right? So what I'm thinking is that we have our iteration, and we have the length of the string, that's not length, divided by 2, I plus plus. Now, remember, this is a even string. Every input is even. So this makes it a lot easier when we're indexing, or somewhat marginally easier when we're indexing, because all we have to do is, let's create two variables to maintain the count. A count for the first half, set them equal to 0. B count for the second half, and we set it equal to 0. Okay, and in this case, all we do is we iterate. So if s dot car at I, that's the ith character, if map of s dot car at I equals 1, a count plus plus. So if we find a vowel in there, and remember we marked off our vowels in there, this tiny little character array by ones, and everything else is 0, then we increment the count for the first half, and then secondly, for the second half, so what's the second half's index? Well, that's easy, right? If we are always if we're always only iterating to half the array, then the top of the half the array is just going to be the iteration shifted by half of the array, right? So we iterate, for example, from book 1, 2, and this will iterate automatically, or 0, 1, and this will automatically iterate 2, 3, for OK, for instance. And that should be it. So then we just want to return a count equals the count. And that should effectively solve the problem. See if this works. That worked on that input. This should work on this input. Okay, true. All right, takes 0 milliseconds, even though there was a appreciable delay. So now let's run this. And there you go. 2 milliseconds faster than 93% of Java's online submissions. Not too bad. Memory usage is 55%, better than 55%. So the top 50th percentile. But I think really the reason why is that there are probably more clever ways of shifting or checking for vowel membership. This type of map-based constant time access for these vowels is probably the fastest you could get using a lookup kind of data structure. So yeah, we can probably do something better in terms of relative offsets of values and things like that. In fact, I think what we could probably do to improve this is that we could check how far the character that we're currently at is from a vowel. So we don't even have to do a lookup at that case. And meaning we subtract the value from, we subtract this from one of those values, and then we don't have to keep any space at all, right? But yeah, so that means like we can say that if s.car at I minus one of these values is equal to 0, and we just iterate through those values, which are the values of these character codes, then we can increment the count. So we could probably try something like that, but I'll leave that up to you as an exercise, and like that's it. And for now, let's call it a night. That's just as a quick programming problem update again. If you like my videos, like, subscribe, and all that stuff. If you want to ask any questions, there shouldn't be for this one. This is a pretty easy problem. Then just let me know in the comments, and I'll see you around.